Hey everybody, Mr. Smith here, and in today's lesson, we're going to review how to solve a quadratic equation. We're going to review, or maybe for you, maybe learn several different methods, and then in practice, you can kind of pick your favorite. And we'll also tie in a little bit our working with radicals when we review the quadratic formula. So as you can see, I'm in my kitchen. The dog may be let out or may need to be let out or let back in. There might be a few interruptions like that, but that's fine. Let's get started. So it's a bit of motivation. So you might recall, like in your grade 10 course, when you were doing quadratic relations, you probably did a lot of projectile problems. And a lot of the equations modeling the height of a projectile looked like this. They always started with like either -5 or -4.9, depending on how accurate the problem would be or needed to be. And then there was always some number times t and always some number on the end for every projectile problem. But those meanings actually, those numbers in front of t in the constant term actually have meaning. For some of you guys who have taken physics, you might know what that meaning is. But the number in front of the t, this v naught, this v sub with the subscript 0, that is the initial speed of the object. And the h naught on the end is the initial height of the object. The -4.9 has something to do with the acceleration of the object, which has something to do with gravity. And if you want to learn more about that, you need to take physics. But yeah, so when if I'm designing a projectile problem for a class, so say I have a projectile that I'm thinking, okay, its vertical speed would be about 45 meters per second, and say it's like a pop fly from a baseball bat, so it was hit from like a height of about 1 meter. I can automatically create an equation that models that. So I used F there. Maybe I might just change that to H because it's the classic way to model height as a function of time is to use H. You can use F too, but let's use H. Makes more sense. So for this projectile, I would say, okay, my function is H of t. So the height in terms of the time is -4.9 times t squared. It's always that for gravity on Earth. And then the initial speed is 45 meters per second, so plus 45t, and then plus 1. So that's how I make a projectile problem. So I just think of my scenario, think about what kind of measurements are realistic, and I have a realistic equation. So that's pretty cool. A type of question you might have done in your grade 10 course is like, when does this projectile hit the ground? So that's when the height is 0. And what you would have to do is then find the value or values of t that make that equation 0. So this is just one application of where we need to solve a quadratic equation. So today we're going to review methods. And if it doesn't seem like review to you, well, that's okay, because we're just going to do some examples and it's a chance to kind of learn as well. So let's dive in. We are going to solve the quadratic equation. So this is just this isn't related to the height question. This is just a quadratic equation, just kind of a random one. 2x squared minus 12x minus 14 equals 0. So we want to know what values of x make that equation true. And I'm going to show you guys 4 methods. And I'm going to show you the first 2, which may be a little bit impractical. And then the final 2 we look at are the ones you're primarily going to use. My dog just came downstairs, so anyway, stop distracting me, Rosie. I'm trying to get some work done here. All right, so I'm going to show you how you can solve an equation by completing this square. So full disclosure, not many people are going to like this. So I would say, like, I'm kind of obligated to show you the method. So we'll do one, and if you want to just choose to forget this method exists, that's totally fine. But I'll show you it one time. So we, as the method says, we take the left-hand side of our equation and we complete the square for it. So if you recall, and honestly, after our lesson on finding max and min, I don't imagine anybody is using this method. I think most people are using the negative b over 2a. But we divide out the 2. And at this point, maybe clean things up a little bit because you can move the 14 over. And then you can divide by 2. So you get x squared minus 6x equals 7, just to make the numbers a bit more manageable. And if you recall, when we complete the square, we want to make a perfect square trinomial. So we do that by dividing the x term in half and squaring it. We're thinking like what number plus itself gives you -6? Well, that's -3. And what's that number times itself? Well, it's 9. So we add 9 and subtract 9 to balance things out. So by adding 9 and subtracting 9, we haven't changed the equation. We did opposite operations. The net change is 0. And again, how did we get that 9? Well, we take -6 and we halve it and we square it. That's where the 9 came from. Because now look what's left over. We have a perfect square trinomial, this bit, that factors to x minus 3 squared. Then we have our -9 equals 7. And the reason why this method works is you've gone from your quadratic equation having x in 2 spots, and now you only have x in 1 spot, which means you can isolate it. If we bring the 9 over, we get x minus 3 squared equals, so 7 plus 9 is 16. And then to undo a square, we can take the root of both sides. So we get x minus 3 equals, now here's the tricky part. If I ask you the question, what number squared gives you 16? Most of you would say, okay, well, that's easy with mental math, it's 4. And you're right. So, x minus 3, 4 works because 4 squared is 16. But there's another number, when you square it, gives you 16. -4. So at the point where you square root each side, it gets a little tricky. You got to remember that there's actually 2 possibilities. And this gives you 2 answers. 7 minus 3 is 4. So x equals 7 is one answer. And then -4 plus 3, -1 is another answer. So you can solve equations by completing the square. But honestly, it's a bit more algebra than most people prefer to do. And you have to remember to make sure to take the positive and negative. So it can be a lot. So not a lot of people like using that method. But again, I'm obligated to show a wide variety of methods, including this one. But now that we've showed it, let's move on. If you want to forget about it, no problem. The second method we can use is we can graph it. So let's do that. Now I'm going to rewrite my equation over here. Where's my equation? 2x squared. And it was minus 12x minus 14 equals 0. Now, if you didn't like the first method, it was a little challenging or impractical, this method's a little impractical too, because if you want to graph from standard form, you either have to, if you want to do it by hand, you either have to factor, which is we're going to do in method 3, or complete the square to be able to get it to vertex form and graph. So it does involve some algebra too. So it might not be everybody's favorite. So I'm going to complete the square for this one. I'm going to do some similar things as the last one. And actually, I want to just mention one extra step here. So what we're doing in this method is we're graphing the function. We're going to graph the function 2x squared minus 12x minus 14. And we're going to see what its x-intercepts are, zeros are. So solving this equation is a lot like finding the zeros of this function. So I'm going to complete the square, and I'm going to do some things I did in the previous question. I'm not going to agonize over the details too much because I know most of you guys aren't using this method. But again, I got to show you it. So we already talked about how to make this a perfect square trinomial. We can add 9, subtract 9. I like to just do one multiplication there to clean things up. 2 times -9 is -18. And then we still have our -14, because then we're done in one step. 2, this trinomial factors to perfect square, x minus 3 squared. We saw that earlier. And -18 minus 14 is -32. Now I can graph this because I know the vertex is at 3 minus 32, which in my scale, these ticks are 2, is here. So that's the vertex 3 minus 32. What's the step pattern for this guy? Well, the step pattern, the a value is 2. So the step pattern is 2. So 2 times 1, 3, 5, your basic step pattern. So 2, 6, 10. Now that's not going to be enough to get us to the x-intercepts. We need to go one more. So if you keep the pattern, adding 4, 14, and that should be enough. So over 1, up 2. What are you doing, Rose? Oh, just knocking stuff over. Over 1 up 2, over 1 up 6, over 1 up 10, and then 14 would be 7 of these squares, and then we get to 7. And if you do the same thing on the other side, over 1, over 2, oh, did I make a mistake there? Yeah, I did. The math teacher can't count. I was a little low on that first one. No big deal. Fix it right up. Over 1 up 2, over 1 up 6, 10, and the last one is 7. That's better. There, and then, wouldn't you know it, guys? When we graphed this function and look for its zeros, we get the same answers as before. We get x equals -1 and x equals 7. So you can solve equations by graphing the function and seeing what the zeros are. Is that method practical? Not really, if it's in standard form, because you got to do some work to make the graph. Now, of course, we could plug it into Desmos and have it do it for us, but to understand what's going on, like that's how you would have to do it by hand. So not very practical either, right? But it is a way to do it. Let's look at some purely algebraic methods that might be a bit easier. We can solve this equation by factoring. So the equation was, again, 2x squared minus 12x minus 14 equals 0. So let's apply our factoring strategies that we reviewed earlier. Can I common factor this expression? Yes, I can. Every number here is divisible by 2. So 2x squared minus 6x minus 7 equals 0. Is there a special pattern here? Is it a difference of squares or a perfect square trinomial? It's not, because that 7 on the end, 7's not a perfect square. So those are out the window right away. So I got to play my numbers game. But is it a simple trinomial or is it complex where I have to use decomposition? This is a simple trinomial. All I need is to find numbers that add to -6 and multiply to -7. This isn't too bad, guys. There's only one pair of numbers that multiplies to 7. 1 and 7. And because they multiply to -7, I know that one of my numbers is positive and one of my numbers is negative. So we just got to think, if we need to make -6, is that going to be -1 and +7 or -7 and +1? Well, it's -7 and +1. Now, to solve an equation by factoring, we use this idea. So that we've factored now, but we haven't actually said what the solutions are. We use this idea that, if I asked you, I'm thinking of some numbers that multiply to 0, you could tell me something about those numbers, because there's only, if things multiply to 0, like one of the numbers has to be 0, right? Like you can't have two non-zero numbers multiply to 0. It doesn't make sense. So when things like 2 times x plus 1 times x minus 7 gives you 0, one of those three things or more has to be 0. Now 2 is obviously not 0. So we ask, well, what makes this bracket equal to 0? Because that would make the whole equation 0. And it's really easy to solve these little brackets equal to 0. They're just little mini equations. So you get -1 And with the second bracket, you set it equal to 0, 7. So we get the same answers as we got before, but we did it by factoring. So to solve by factoring, factor if you can, set the factors to 0, and solve those little mini equations. So that is a method that's taught in the grade 10 course. Maybe you got to it and maybe you didn't, but it's not that bad to apply. And that brings us to the fourth method, which is, frankly, it's in my opinion, it's most people's preferred method. And the reason is it's just the same every time. I don't have to worry about completing the square. If factoring is a challenge, there's no factoring. It's a formula. You use the formula and it works every time. So it's the quadratic formula. So the quadratic formula depending on who your teacher was, they may have shown you where this formula comes from, or maybe not. That's not really important for you guys in this course. It's now just a tool that you can always use. This formula always gives you the x-intercepts of a parabola or solves a quadratic equation if there are solutions. And so let's do that for ours. So our function was, or our equation, 2x squared minus 12x minus 14 equals 0. So we have a equals 2, b equals minus 12, and c equals minus 14. And if you can imagine how many different high school math teachers there are in Ontario or even Canada or the world, like all of them have their preferred way of working with the quadratic formula. So I'm going to show you like how I would do it, but if you have a way that you're comfortable doing it, that's totally fine. So I'm just going to plug right in. Negative b would be 12. If b is negative 12, the opposite of that is positive 12. Plus or minus, the plus or minus, because we can get two solutions. The root of negative 12 squared minus 4, a is 2, c is minus 14. All divided by 2a, 2 times 2. Now, at this step, I like to show a little bit of work. So I'll do everything under the square root at once. So that's minus 12 squared is 144. And then be careful with negatives, right? Because that's negative 4 times 2 times negative 14. That would give you a positive. So 4 times 2 times 14 is 112, I think. Yeah, 112. So I'm doing 144 plus 112. I mean, I'm just using order of operations, right? It's like should be no big deal for us. Divided by 4. And then I just work it out. So in this case, the root of 256 is a perfect square number. So that's 12 plus or minus the root of 256 is 16 divided by 4. And then I'm just going to go up here. And now I'll just write my two solutions. So my first solution is 12 plus 16 divided by 4. So it's 28 divided by 4. Now I might show an extra step here and just write that out. I'm okay if you just go right to your answer. But that's 28 divided by 4, that's 7. And x2 would be 12 minus 16 over 4. x2 equals negative 1. So I showed a lot of work there. I've said to you guys, I say to all my math classes, like if you're just doing a lot of problems in your notes, like shave off some steps. Like if you know what you're doing and you can read your work and you understand what you were doing, shave off some steps. If you're submitting something to be looked at, I'd probably put your best foot forward and do an organized solution. Most of your time, your math teachers will show a lot of steps anyway, just to kind of help people that are learning. So this would be a really good amount of work, but like there's spaces to shave off some steps for sure. So if you guys will notice, we got the same answer with all 4 methods. And I'll tell you that, when we're solving equations together in our work, if something can easily be factored, I'll factor. If an equation looks like it'd be really hard to factor or it can't be factored, then I just use a quadratic formula because I know it always works. And you guys can use any method you want. If you're comfortable with the quadratic formula, just use that. All right, so a little bit of review, some terminology. Um, when you're solving a quadratic equation, if you think back to the graphing example, solving a quadratic equation is a lot like graphing the function and finding the zeros or the x-intercepts. Why am I going? Oh, I'm hitting the left button. That's why I was going back to the start. So for parabolas, there's three possibilities, right? A parabola can have two x-intercepts. So that's like remember our previous question? Our previous one had two x-intercepts. So when we solved that equation, we got two values, right? But does every parabola have two x-intercepts? Well, no. Some parabolas have, some parabolas have just one x-intercept, where that x-intercept is the vertex. So you know how in the quadratic formula, where you have your plus and your minus, that allows you to get two different x-intercepts. But in the case where there's one x-intercept, we say there are two roots, but they're equal roots. Honestly, another way of saying this is just that there is one real root, or one distinct real root. Those two things, they mean the same thing. And finally, a parabola doesn't have to have any x-intercepts. So in those cases, we would say there's no real roots. And is there a way to determine which case it will be kind of ahead of time to maybe save you some work, or to help you understand as you're using the quadratic formula, to help you understand, depending on what you get mathematically, you know which of these cases it is. And the key is the expression under the radical sign. Under the radical sign, b squared minus 4ac. This is called the discriminant. Discriminant. And the value of this expression determines the number of solutions a quadratic equation has. So if b squared minus 4ac, the discriminant, is greater than 0 or positive, let's think about this, guys. If underneath the square root is a positive number, we'll be adding something and subtracting something and getting two different answers, right? So if b squared minus 4ac is greater than 0, there are two, I'm just going to say two solutions. Keep the terminology simple for you guys. If b squared minus 4ac is 0, well, the square root of 0 is 0. You'd be adding 0 and subtracting 0. That gives you the same value. So what you end up getting in those cases is you get one solution, because adding 0, subtracting 0 are the same thing. And then when b squared minus 4ac is less than 0, well, you can't root a negative number, right? So if b squared minus 4ac is negative, the quadratic formula breaks down, which is okay, actually, because if there's no solutions or no x-intercepts, we don't want the quadratic formula to say there is. That'd be confusing. So that's how it breaks down. So that's kind of nice. At least I think it is. 0 solutions. And that's just a bit of review. So that's not crazy. Like, you guys cover that in grade 10 and we're evaluated on that. This is just a bit of review. So just kind of talking about that. All right, let's go on to actually just getting you guys to try solving some equations. So we have 4 methods, and I'm never going to force you to use one over the other. But I've asked you here to just try to factor these guys. They each involve trinomial factoring. I'll even give you a hint. The first one is a simple trinomial. The second one, you'll have to use decomposition. So give it a try. Ultimately, you could use the quadratic formula, but again, I will say there are times in this course where we have to factor. It is what it is. It's a skill you guys did learn about in grade 10, or at least learned a bit about. And at this stage in the game, in the 3U math course, we just have to be able to factor. We need factoring in every grade moving forward. It's just a skill we need. So if you're still struggling with factoring, hopefully you practiced earlier when we did our review lesson, but get some help. I'd love to help you. There's lots of resources. Factoring is a skill that we can acquire with practice. I know we can. So if you want to pause the video and try these two guys. You can unpause when you're ready and see how you did. All right. So I'm going to come along for the ride here. Let's solve these by factoring. So first one is a simple trinomial. I need numbers that add to -1, multiply to -12. Those numbers are -4 and +3. Once you've factored, you set each bracket to 0. Many of you could just read off the solution from the brackets, but I will show this step. So x equals 4 is one solution. X equals -3, another solution. Perfect. All right, let's look at B. So B is a complex trinomial. We'll need to use decomposition. We want numbers that add to -5 and multiply to 2 times -12, -24. Those two numbers are -8 and +3. So I'll decompose my middle term into those two numbers. And then it's common factor, common factor, common factor. Common factor the first pair. You can take out a 2x, and you're left with x minus 4. Common factor the second pair. You can take out a 3, and you're left with x minus 4. This is good. Same value. Common factor one more time. X minus 4 is now in common, and we have a 2x and a 3. 2x plus 3 equals 0. We've now factored. What are the solutions? Many of you could probably just pick off the first solution. It's x equals 4. But those people who try just to read off their answers from the brackets can get into trouble with a bracket like this. We have to set that bracket to 0 and solve. So we get 2x equals -3, and we get x equals -3/2. Or -1.5 would be a nice decimal for that. But yeah, so be careful if you're just trying to read from the brackets. You would move the -3 over and divide by 2. So in my opinion, looking at A was pretty easy to factor, went pretty quick. For B, if it takes you less time to use the quadratic formula, then just do that. But factoring works. And as I said, if I can easily factor, I'm going to factor. And yeah, I just eventually I got to stop apologizing that we have to factor. That's the last time I will. We got to factor. All right. So the next little exercise, I have 4 quadratic equations for you guys to solve using the quadratic formula. And I've set up the first one for you. And what we're going to do here is we are going to find the exact answers. So in each one of these, we're going to do a bit of, if we don't get a perfect square number inside the radical, we're going to do some simplifying. So you know what? Maybe I'll show you what I mean by that. Let's finish off A. So we have 13 plus or minus. So what do we get inside that root? 13 squared is 169. And 169 minus 20, that's 149. All divided by 2. So this is exact. In your grade 10 course, in these kind of situations, you would have taken the root of 149 and got some decimal answers. But we're actually going to stop here. Now it is worth checking, are there any perfect square numbers that go into 149? And my knee-jerk reaction was to say there aren't, but all of a sudden I'm doubting myself. But no, there aren't. That can't be simplified anymore using our rules. This one is done. Those are the roots. 13 plus the root of 149/2, and 13 minus the root 49/2. Exact roots. We're done. Let's do the second one. Of course, I've forgotten the 0 here. So let's try this one. So x equals, so -15 plus or minus the root of 15 squared minus 4 times 2 times 7, all divided by 2 times 2. So we get -15 plus or minus. So let's see what we get. Do we get a perfect square number, or do we get something like root 149 again, where we're just done? Or maybe we get something we can simplify. So 225 is 15 squared. 8 times 7 is 56. We get 169, which is good for us because 169 is actually a perfect square number. Gives you 13. And then you can get your two answers. So show as many steps as you need to, but we're just using plus and then minus. So minus 15 plus 13 is negative 2. So negative 2 over 4 is negative a half. Or negative 15 minus 13, that's negative 28. Negative 28 divided by 4 is negative 7. So in this case, the exact answers, like we just took it all the way to the end, and our answers are exact. Those are exact. But we couldn't do that with part A, right? Part A, you can't do the root of 149 nicely. So you're just done. You leave it in radical form. All right, so I've kind of done two with you guys. Maybe you want to try C and D on your own completely, like pause the video and just open it up when you're ready to check. And that would be encouraged. Of course, you're always welcome to just follow along with me, and I'll just do these last two, and we'll call that a good lesson. Just gonna have a drink first. All right, so let's do this one. So quadratic formula, negative b, so that'd be positive 10, plus or minus the root of negative 10 squared, minus 4 times 5 times 5, all over 2 times 5. I think I see where this one's going. So we get 10 plus or minus the root of, so that's 100, and then 4 times 5 times 5 is 100 as well. So it's 100 take away 100, the root of 0, all over 10. So this is our case where the discriminant is 0, and we're going to get exactly one distinct real root, or two equal real roots, because 10 plus 0 is the same as 10 minus 0. And you just get 10 over 10, you just get 1. X equals 1 is like the only solution to this one. All right, what's going to happen in D? Let's check it out. Negative 4 plus or minus the root of, so b squared, so 4 squared, minus 4, a is 1, and c is negative 1. All over 2a, so 2 times 1. So we get negative 4 plus or minus, so that's 16, and then because it's double negative, it'd be 16 plus 4. So inside the radicand there, we're going to have 20. Or sorry, inside the radical, we have a radicand of 20. So we get negative 4 plus or minus the root of 20 over 2. Now I want to ask you guys, is this like part A, where we're done? Or can we simplify this any further? Think back to our previous lesson, the root of 20. Can we simplify that radical? And the answer is yes, we can. We can write 20 as 4 times 5 and reduce that a little bit. The root of 4 is 2. So we get negative 4 plus or minus 2 root 5 on top over 2. And then check out what happens, guys. Negative 4 divided by 2. Negative 4 over 2 is negative 2. Plus or minus 2 over 2 is 1. And so this 2 root 5, when you divide it by 2, you're left with root 5. And so here are your two, the two roots in exact form. Negative 2 plus root 5 and negative 2 minus root 5. But they're written in exact form. They are nice and compact, written in a nice compact way. So very elegant, really nice. I really enjoy this topic. Maybe you find it dry, but I quite like it. So here's the thing, guys. Is finding decimals bad? No. Like, again, I always use the example. If my wife sends me out to the store for something, I'm not going to the counter and saying, hey, can you give me -2 plus √5 of this? That's silly. You get the decimal, right? But in a lot of applications, we want to be precise, so we want the exact form. And moreover, like, this is correct, and it is exact. There's nothing really wrong with it. However, when we can simplify, we want to. So this is even more correct. And when you do certain questions in your text, and you're actually moving forward in later grades, resources are always going to simplify. So if you're looking in your solutions for -4 plus or minus √20/2, you're not going to see it. You're going to see -2 plus or minus √5. And students who don't quite have that understanding think, oh, what did I do wrong? I got it wrong. And then it's not about that. You didn't do anything wrong. Your answers are the same. It's just one is more simplified than the other. Yeah, guys, those are the 4 methods. So that was a lot of review. However, using the quadratic formula, what we want to be able to do now is, if we want our answers in exact form, we can simplify them if necessary, like part D. So that's the long and short of it. What I absolutely need you guys to be able to do is, if I gave you an equation, you can solve it, whether that's by factoring, if you are okay with factoring, or at the very least, you have to be able to apply the quadratic formula. And the new learning is, addition to that, write your answers in exact form by simplifying. All right, guys, that was quite enjoyable. In our next lesson, we're going to look at groups of functions that share a common property. And we're going to call these families of functions. So what most of you will find, hopefully, is that it's actually just more review. So that's really good. More review, more time to get back in the swing of things. But until then, hope you guys are staying well. Have a great day, and we'll see you soon.